the bond energy below to calculate the enthalpy change of combustion of alkanol with N is equal to. So we want now to calculate the heat of combustion using this equation. So I have rewritten the equation here, as you can see. So the next thing now, most important thing is to open, to write the open structure of whatever is involved here. So here we will have carbon surrounded with 3 hydrogen. So one, another one, another one. Next we have this carbon surrounded with 2 hydrogen, one here, another one here. And then next we have OH. OH plus 3 oxygen. Remember, oxygen is oxygen the double bond. So this one needs you to understand very well bonding, how molecules bond. So this is a covalent bond between oxygen and oxygen. Next one we are going to have 2. Then also you need to know how carbon 4 oxide forms the bonds. So that was the problem that the students were facing. They did not know how to open these structures. There are 2 of them, and then finally we have water, which is 3H dash O dash H. We have 2 hydrogen, oxygen, that's hydrogen, oxygen, hydrogen. That makes water. So once you have done that, you can clearly see that on the left side here, this one is called bond. Up to here is bond breaking energy. Bond breaking is always endothermic. Endothermic. From here, after the arrow, we have bond formation. Bond formation, which is always exothermic. Which is exothermic. Now, one carbon hydrogen bond is here. 1 carbon hydrogen bond is 412 kilojoules per mole, per 1 mole. So we have 4. How many are they? 1, 2, 3, 4, 5. So we have 5 times 412. So that one will give us the energy for carbon hydrogen. And then we add, there is carbon bond. So carbon bond, we have 348. Plus, we have here carbon oxygen bond. Carbon oxygen bond, which requires 360. Next, we have oxygen hydrogen bond, which is 463. 463. And then here we have plus oxygen bond. 1 oxygen bond, it is 496. So these 3 is very important. These are 3 moles of oxygen gas. This means 3 moles of oxygen. This energy here is for 1 mole per mole. So that's why it was very important for you to balance the equation. Anybody who did not balance the equation will not score this question. So you need to balance the question. So 1 mole is 496. Now what will be 3 moles? So that one will be 3 times 496. 496. And this one will give us the total for the bond breaking, which is 4719 kilojoules per mole. Now we are on the right side, bond breaking. On bond breaking, we have the first bond, which is oxygen carbon. So we have carbon oxygen. Whether it is oxygen carbon oxygen is the same thing. So one is, so we have carbon, we have two of them already, this one and this one. So this is 2 times 2, which is 4. So we can put 2 here, this 2 into carbon oxygen is 7, 43. That is 1. But inside here there are 2 of them, so times 2, like that. Plus 3 oxygen hydrogen. Oxygen hydrogen or hydrogen oxygen is the same. So we will open bracket, there are 2 of them. So 2 times 1 is 463. So by so doing, you will have the total as 5750. So we know that bond, okay, enthalpy change of combustion of ethanol is equal to bond breaking energy plus bond formation energy. So this what means is that now we know this one is endothermic. We just write 4719 then plus, but we know that whatever we are adding here is exothermic. The answer, this one is exothermic. It should always be negative, so negative 5750. So this one will give us negative 1031 kilojoules per mole.